Jai Hind, welcome to the course Network Analysis and Synthesis, and I am going to discuss superposition theorem of this course, and this theorem is applied to AC and DC circuits, and these circuits are containing both independent and dependent sources. The first and foremost I am going to discuss about the what is superposition theorem. So, superposition theorem is applied to any linear circuit. So, if any linear circuit, there are a number of voltage and current sources are acting simultaneously in a linear network. So, the resultant current in any branch of the circuit is the algebraic sum of the current that would be produced if each current source acts alone while other energy sources are replaced by their internal impedances. So, here the word algebraic is used to indicate that we take into account reference polarity of a voltage source and reference direction in case of current source. So, there are two aspects of superposition, and first is the additive property and that is the homogeneity property. What do you mean by additive property? So, suppose if an excitation E1 gives a response R1t and an excitation E2 gives a response R2t, then by superposition theorem the excitation E1 and E2 would give a response R1 plus R2. So, basically this is for the to check the linearity of the circuit, this must be satisfied. Second is the homogeneity. Suppose an excitation K1 ET and excitation K2 ET occurring together would give a response K1 R1T and K2 basically K2 R2T, K2 R2T. So, if the response is excited by multiplied by some constant, so we can get the just same multiplication in the output also. So, these are the two properties justify the principle of superposition in a network. Now, proof. Take a very simple resistive network containing two energy sources E1 and E2, and these energy sources are ideal in nature. So, suppose I want to find the current through any branch of the network. So, what I have to do? I have to first find the current through any element of the network when both the sources are acting together. Then the second step is take one source, say E1 voltage source is acting while the E2 voltage source is replaced by its internal impedance, and the third step, keep E2 active and replace E1 by its internal impedance, and we can check whether the summation of this current is same as the current we obtained when both the sources are acting together. So, first find the current, we just apply the Kirchhoff's voltage law in both the loops. So, these two equations we can obtain by writing the Kirchhoff's voltage law. Then on simplifications we can get the I1 and we can get the I2. So, these are the two expressions for I1 and I2 by just simplifying, solving these two equations. Now, suppose E2 is inoperative, means it is replaced by its internal impedance, and we can see that the E2 is an ideal voltage source. So, internal impedance of E2 is 0. So, internal impedance of E2 is 0. So, it will be replaced by a zero resistance wire. So, it looks like a short circuit. So, E2 is operating and E1 is working. So, in this case find the value of I1 dash and I2 dash. So, simply just apply the Kirchhoff's voltage law, write two equations, this is first equation, this is the second equations, and on simplifications we can get I1 dash and I2 dash. So, these are the currents I1 dash and I2 dash when the E1 voltage source is acting, while E2 voltage source is replaced by its internal impedance. Now, take the E1 voltage source inoperative. So, E2 is acting and E1 is replaced by its internal impedance. Again E1 is an ideal voltage source, it will be replaced by its zero resistance wire. So, it looks like a short circuit. Now, in this case try to find the I1 double dash and I2 double dash. What we will do, just write two Kirchhoff's voltage law equations, this and this, and just on solving we can get I1 double dash and we can get I2 double dash. Now, this I1 dash is due to E1, this I2 dash is due to E1, and this I1 double dash is due to E2 and I2 double dash due to the E2. So, now if we take I1 is equal to I1 dash plus I1 double dash, if we are able to prove this, then theorem is verified. Okay. So, if we do this, so I1 is equal to I1 double dash plus I1 dash and I2 is I2 dash plus I2 double dash. So, hence the theorem proved. So, this proof is very simple. Take the response of the circuit when both the energy sources are acting, and take then the next step, take one energy source is acting while the other energy source is replaced by the internal impedance. In the third step, take the second energy source is acting while the first one is replaced by its internal impedance, and then we can verify. If this is satisfied, then theorem is verified. The proof is very simple. Now, we do some examples just to carry out the verification of. Now, before solving some examples, what are the steps to carry out the superposition theorem? So, first step is only one source is considered. We have seen while proving this theorem. The other sources are replaced by their internal impedances. If there are more than two energy sources, take one at a time and replace other energy sources by their internal impedances. The ideal independent voltage sources are short circuited. We can see that because it has zero resistance wire, so it looks like a short circuit, and ideal dependent current independent current sources are open circuited, because the internal impedance of ideal current source is infinite. So, it looks like a open circuit, and all dependent sources will act normally. So, only we replace the independent sources, and all the dependent sources will act normally, and we must take care of this. Okay. Now, using any suitable network analysis technique, depending upon the type of the network circuit configuration, we can apply either Kirchhoff's voltage law or Kirchhoff's current law. The current through or voltage across the desired element is found due to the source under consideration. The above steps are repeated considering all independent sources one by one. Okay, and the total response, either voltage or current, is obtained by the algebraic summation of the responses. What is the application of this theorem? This theorem is valid for all types of linear circuits having time varying or time invariant. This theorem is used to find the current or voltage in a branch when the circuit has a large number of independent sources. This theorem is not valid for power relationship. Why? Because power is a nonlinear quantity. Power is a nonlinear quantity. So, this theorem is not applicable to circuits containing only dependent sources. Okay. These are the some limitations. This theorem is not applicable to circuit with nonlinear elements. This is not useful for only one div. So these are the limitations of this theorem. Not applicable to nonlinear circuit. The circuit must have a more than one independent energy sources. Now we do some problems. Suppose this circuit, there we can see that there are two energy sources, both are voltage sources and they are ideal in nature. And what we have to do, we have to find the current through the capacitor. We have to find the current through this capacitor using superposition theorem. So what we will do, first we will take one energy source, replace other one by their internal impedance. So look at, we are considering the 50 angle 0 degree voltage source is active, while the 100 angle 0 degree voltage source is inactive, or it is replaced by their internal impedance. So it is the equivalent circuit, we can see here. So this voltage source is replaced by this zero resistance wire, so it looks like a short circuit. In this case we have to find the current through this capacitor. So we can see that this 50 angle 0 degree voltage source is applied across this. So voltage across this capacitive reactance is 50. So simple, we can apply the Ohm's law and we can find the current through the capacitor. So this is the voltage across the capacitor and this is the capacitive reactance. So with this is the current through the capacitor when 50 angle 0 degree voltage source is acting, while 100 angle 0 degree voltage source is replaced by the internal impedance. So this is the current, I1, you can say. Okay. So this is the plus here and this is the minus here. The current will flow from top to bottom. So direction will be like this. So in superposition theorem, direction and polarity, if you are going to obtain the voltage developed across any element, we have to consider the polarity of that voltage. If you are going to consider the current, we must consider the direction of the current. So in this case the current is flowing from top to bottom. Now take the another energy source, that is the 50 angle voltage source is inoperative and 100 angle 0 degree voltage source is active. So this is replaced by its internal impedance and it is in ideal nature. So internal resistance of this is 0. So this is a basically 0 resistance wire. This is 0 resistance wire. So it looks like a short circuit. We don't do the short circuiting and open circuiting, because we just replace by its internal impedance. If suppose if this voltage source having some impedances, say it has 2 ohm, 3 ohm. So here we have to insert the 2 ohm resistor. Okay. So in this case the current through the capacitor is 0. Why it is 0? Because this is the 0 resistance wire. So suppose current is supplied by this source, so some current will go through this, some will come through this. This current is reaching at this point. So at this point the whole current will pass through this. Why? Because current follows minimum resistive path. To hold the current that was flowing through the 5 ohm resistor will flow through this 0 resistance wire. This is the 0 resistance wire. So in this case I2 is 0. So the using superposition theorem, this is the I1 plus I2. So it is 10 angle 90 degree ampere. So this is the current flowing through the capacitor. Take another example. Here in this case we have to find the voltage across 1 ohm resistor using superposition theorem. So first consider 1 ampere current source while replacing 1 volt voltage source by internal impedance. Simple, replaced. So this has the 0 resistance wire. So this is short circuit. So this impedance is not active in this network. So it has been removed. So the circuit is like this. So in this case Simple, this 1 ampere current source is reaching here. Okay. So some current will go through this, some current will go through this. So just apply current division, just apply the current division rule. The voltage across, so current division is, so this current through the, say this I1 is 1 into J1 upon 1 plus J, okay, and V1 is equal to I1 into this 1 ohm resistor 1. So this is J plus 1 plus J, okay. This way we can get. Now come to here. Now the one voltage source is acting while 1 ampere current source is replaced by internal impedance. So this current source is ideal in nature. So it has infinite internal resistance. So this is the infinite. So it looks like an open circuit. So this voltage source, this is this point is here plus and there is minus. So this whole voltage source is applied across this. So this I1 dash is 1 divided by 1 plus J, and this I1 is 1 by J. So using superposition B dash. So here also the polarity is plus minus, here is also the polarity is plus minus. So this B dash plus B1 is 1, okay. So this way we can solve the circuits using the superposition theorem. Now come to another example. In this there are two independent voltage sources, two independent energy sources, and there is one dependent. Which type of this source is? This is voltage control. This is voltage controlled voltage source. This dependent source is voltage controlled voltage source. So take one energy source, 18 volt voltage source, while replacing 3 ampere current source by internal impedance. So it is ideal in nature. So it is infinite resistance. Now try to find the value of I1, okay. So what we will do, just apply the Kirchhoff's voltage law in this loop, outer loop. So 18 volt minus 2 plus, so 18, then minus I1 means current is flowing in this direction. So current is flowing in this direction. So for the current reference, here will be the plus, here will be the minus, okay. So minus I1, then come to here, it is minus 2 plus, so it is twice B double X. Here is plus, here is minus, current is flowing from top to bottom. So here is a plus terminal, minus terminal, so minus 6 I1. Clear this equation? Now there are two unknowns, I1 and Vx dash, and we have just written one equation. So one more equation is required to solve this equation. So look at here. What is the relationship between this Vx dash and I1? I1 is flowing, okay. So due to the I1, the drop is minus I1 into 1, and we can see that in the given circuit, this Vx dash has polarity plus to minus. So what we conclude? We conclude that Vx dash is minus I1. Please look at here. In the original circuit, here is the plus minus, here the plus, here is the minus. Polarity of the Vx is given, but due to I1, the drop is plus here and minus here. It means this voltage is opposing the flow of the current. So Vx dash is minus I1. Now put we can get I1 is equal to 2 ampere. I1 is equal to 2 ampere. So either put Vx dash is equal to minus I1, and on simplification we can get it. minus 6 I1 and there minus 2 I1 minus 3 I1, so 9 I1, so 9 I1 is equal to 18, so it is 2 ampere. Now consider the 3 ampere current source while replacing 18 volt voltage source by its internal impedance here. It is ideal in nature, so it is zero resistance wire. Now look at here. Now this 3 ampere current is approaching this node. So sum of the current, suppose I2 is flowing this side, so this side will be 3 minus I2 will flow through the 1 ohm resistor. 3 ampere current is approaching this node, I2 current is flowing through the 6 ohm resistor, say. It means 3 minus I2 will flow through the 1 ohm resistor, and then apply the Kirchhoff's voltage law. So 6 I2 starting from here, 6 I2, here is minus, here is plus. So minus to plus, so 6 I2, plus to minus, so minus 2 Vx dash. Then here the current is flowing from here, this side to this side. So in this case, 3 minus I2 current is supporting the polarity of the voltage. So the voltage polarity Vx double dash is plus minus. So this current, due to current, the drop will be hello plus or minus. So this, and then equal to 0. So again two equations, two unknowns, and we need one more equation. So one more equation will like this. Look at here. Here Vx double dash is 3 minus I2. Whereas in the previous circuit it was Vx dash was minus I1. Here Vx double dash is 3 minus I2, because in this case it is supporting the polarity of this voltage Vx double dash. Okay. So on simplification we can get I2. So I2 is 1 ampere. So using superposition theorem, again I2 is flowing from top to bottom. So it is algebraic summation. So same for due to the 18 volt, the I1 was flowing from top to bottom, and due to 3 ampere current source, I2 is flowing also from the top to bottom. So here it will be get the plus sign. So 3 ampere. Now look another examples. Current through 5 ohm resistor using superposition theorem. Again 3 energy sources, 2 are independent, 1 dependent. So this is voltage controlled current source. This is a current source controlled by the voltage of this. So take one energy source, say this I have taken the 5 ampere current source while replacing 10 volt voltage source by internal impedance. Now we can write the KCL at point node. So 5 ampere is approaching node, Vx dash upon 10 will flow through this like this, and we can also see that this voltage dash is across this 5 ohm resistor. So current I1 will also be V0 dash upon 5 plus V0 dash. So we can write one current variable, 1, 2, 3, 4. So there are 3 current variables. This is the first one. This is approaching towards node A. V0 dash upon 10. This is current through this 10 ohm resistor. And again V0 dash upon 5, because this voltage is, because 5 ohm and 10 ohm both are in parallel. So voltage across 5 ohm resistor will also be V0 dash. So V0 dash upon 5 is the current through the 5 ohm resistor plus this current V0 dash upon 2. So we can get V0 dash is equal to 50 upon 8 volt. Now so we can get the I1. What I have to find? I have to find the current. So this is the current through this 5 ohm resistor using the 5 ampere current source is 5 by 4 ampere, and it is flowing from top to bottom. Now consider the 10 volt voltage source replacing 5 ampere current source by internal impedance. So it is an ideal current source, so infinite it will be replaced by the infinite impedance. Now again look at here, apply Kirchhoff's voltage law in this circuit. So starting from here, -2 plus, so V0 double dash, plus -2 plus, so it is plus 10, minus 5I2. Here it will be plus, here will be minus, because current flows from higher potential to lower potential. So this is, so there are two unknowns, V0 double dash and 5I2. So again we have to look for another equation. So look at here, V0 current through this is V0 double dash upon 2, current through this is I2. So some current will flow through this. What is that current? What is that current flowing through this 10 volt and 50 double dash? Suppose these 10 volt and V0 double dash, they are in this 10 volt and 10 ohm resistor, they are in series. So in the series current is same. So what is the current through this V0 double dash? It is V0 double dash by 10. So V0 double dash by 10 is the current flowing through the this branch. This current is flowing, because 10 volt and V0 dash both are in series. So in the series current is same. Now I2 it away and V0 double dash by 2. So all three current variables are leaving the this node. Say this point is, say this point B is. So apply, what I have to apply, Kirchhoff's current law at node B. Simple, at node B. So node B, so we can write, understand, because this is the current is this voltage upon this impedance, and this current is flowing through this 10 volt. So this is, so we have two unknowns, two equations. On simplification we can get I2. So I2 is 3 by 2 ampere. So using superposition, I is equal to I1 plus I2. So this is 11 by 4 ampere. So this is the answer. So we can get the current through the 5 ohm resistor using the superposition. Look at, there are two energy sources and three energy sources. Two are independent and third one is the dependent. So we just replace, consider independent energy source at a time, keeping dependent energy source in the circuit. Okay, we do not remove. Okay, be careful. Now this is another problem. We have to find the current through the 4 ohm resistor, through this resistor. So what, just this, take the parallel combination of this. So replacing this one, considering this one, so this, so they are in parallel, so say this is Z1, this is Z2. So this is your Z1, this is your Z1 and this is your Z2. Just simplify this circuit and it will be look like this. So this is Z1 and this is Z2. Now it is very easy to find the current through using current division. Current division. So I1 is total current into impedance of this branch Z1 divided by Z1 plus 4 plus Z2. So this is the current through 4 ohm resistor Now consider this voltage source, replace this current source by its internal impedance. So, internal impedance is infinite. Again find the current through this. So, this is the circuit. Now, we can find the current through this. We have to find this current. So, just two loops, so two KVLs equations, and write the KVL equations in these two loops. On simplification we can get I2. So, this is the your I2 which is flowing in this direction here. Look at. So, in this direction the flow of current is in this direction, say B to A, whereas while considering the current source, the current was flowing from A to B. So, that is why we have taken here I1 minus I2, algebraic summation. So, I1 minus I2 here, look at here. So, this is this, we can get this. So, this is the net current flowing through 4 ampere when both the energy sources are acting using the superposition. So, because you have to take one energy source at a time. Okay. So, we just discussed superposition theorem considering the energy sources dependent and independent. In the next class we do some another topic. Thank you very much. Jai Hind.